Okay, so in this video, we're going to have a quick overview of Terraform, what it does, and a quick example. So HashiCorp, the parent company of Terraform, defines it as an open source infrastructure as code software tool that provides a consistent CLI workflow to manage hundreds of cloud services. Terraform codifies cloud APIs into declarative configuration files. So the operative word here is declarative. Instead of taking the imperative steps to provision infrastructure, meaning 10 different bash scripts, 4 different GUIs, and then a myriad of other things to provision a single database, anything like that. You can have modular codified configuration files that declare the desired end goal, and Terraform through various providers such as AWS, Google Cloud Platform, Azure, and more that handles these imperative steps. So this allows you to have a consistent, modularized, and codified infrastructure that is more robust and can embody the combined knowledge and understanding of multiple teams. So right here, you can see we have a Terraform file pulled up. It does look pretty similar to JSON, and slightly different flavor called HCL, or HashiCorp Configuration Language. So the key elements to the HCL syntax are blocks and arguments. So arguments, as you can probably assume, they assign values to names, right? So we've got name and a value, a string value. And then blocks, which are anything that's within these curly brackets. So blocks has, or each block has a type and one or more labels. And that is dependent on the provider. The provider only has a certain amount of resource blocks. So in this case, this resource is the provider. Here we can see, here is the type. So this provider block type is Google. This resource block type is a Google SQL database. And then the name on this one, or the type, is going to be database labeled Terraform. And so that is how you distinguish, in your own words, the different resource blocks. And that's how you also reference it throughout the other Terraform code. So the amount and capability of different providers is increasing as Terraform becomes more widely used. So if we want, we can go here, go into the Terraform registry, Google, and we can look at what Google has, all of their resources that you can provision using Terraform. You see there's quite a few there. And we'll be doing maybe Cloud SQL on this or a different video, as well as Compute Engine. Okay, so let's go look into the file. And I'll actually open up this real quick. Okay, so in this file, what we're going to be doing is provisioning a database using the Cloud SQL resource, as well as a single user. So this requires a few different blocks, and we'll walk through it. So you see, first we have our provider block. The provider defines what essentially interface or what mapping Terraform is going to download and look at. So it's going to download the Google one, and then we've defined within this, here's kind of a configuration to say we're using this project, and the resources we want to create are going to be used in these regions and zones or data centers. And now it comes more into play when you're looking at high availability or things like that. So that's defining, here's kind of our configuration, and then here is where we get to the meat of things, is the resource blocks. So you can see we've talked about, we've got our type, so we're instantiating a Google SQL database, and the name or the label of this is going to be database label Terraform. And the name here is an assignment that's within Google. So when we open this up, it's going to show my Postgres database within Google Cloud Platform. And that references this resource, as you can see. So we're referencing the type, Google SQL database instance, .instance label Terraform, .name. And so those are some of the parameters that you need to pass as part of instantiating this. You see the next resource we have is the actual instance. We've labeled it. It has a name, has a region, has a database version. So we do Postgres, and we do MySQL, SQL Server. And I've also defined here is the resource type. And so this is the smallest one, so we won't use up our credits that fast. And deletion protection is true. And so we're going to go ahead and just set that to false so we can delete it with Terraform. And then here we have another resource. of creating a Google SQL user. And the name, we can just do SQL user Terraform, right? The name will be example user. The instance will refer to this block. You can see this as we did it before. And then the password will be not so secure. So we have it here in Visual Studio Code because it looks nice and pretty. And so we're going to actually run it in Cloud Platform. And it's not as pretty, the editor there. What we're going to use is the Cloud Shell. I've got the text up a little higher. We'll bring it there, and I'm in a, actually, let's go through and write over this file real quick to what I had. Make sure that's up to date. And we're going to go back to the terminal. You see here we've got our main.tf. We can show what it is. That's what we just looked at. Not as pretty. But then we get into the workflow of Terraform. So the core Terraform workflow is described as having 3 steps that iterate upon each other. So they are write, plan, apply. So the latter 2 correlate with actual commands you will run in the terminal here in a second. But as you can see, we're kind of in the write phase. We're going to write, we're going to understand here's what we need. And then we will say Terraform plan. Terraform will look at the current state of things, the way Terraform, the engine is seeing what is the current state of this infrastructure. And then based off of that, we can run and apply, and that will make those changes. So before that, the first thing we need to do is init. And so that is similar to like an npm install or pip install, where you take your packages or your providers and it downloads that. We run our Terraform init. You see Terraform has been successfully initialized, download the provider. And here we haven't set the version, so I think it defaults to the most recent version. And now you can begin working with Terraform. Try writing a Terraform plan, so let's see what that pulls up. That's a lot right there. But what we're seeing is it's going to create 3 resources. Anything that has pluses, it's going to create something that wasn't already there. So here are some of the fields you can put in there that we did not, that are going to be automatically generated. So you can see right here, we've got our instance here, name that we've defined. Here's a single resource. Here's another resource. And here's all the different values that are going to be generated as part of Terraform, its plan. Whereas with maybe a more imperative way of declaring this or instantiating this, we might have to have hundreds of lines or even more of scripting or thousands of clicks in a GUI to get this done. So we can see there's the user, we've got the database, we've got the instance. So plan is 3 to add, 0 to change, 0 to destroy. Where we're good with that, Terraform apply, and that will bring up the same output as plan, and then ask you to enter a value if you're willing to accept this. Perform these actions, yes. Now this part does take a little while, so we'll hop back on when it's done. So if we want to check, we can actually just go in to the interface here, and it should be under Databases SQL. You can pin those, as you can see. We should actually see that it's starting to spin up. See the instance has spun up, but the database is still spinning up. You can click into this. Now it's loading up the database right now, Postgres. Creating everything. Postgres user, it hasn't added our user just yet. It's still creating. We'll wait for that to finish. So I'm not quite sure why this is still running, but it looks like it's provisioned pretty much everything. You can see we've got one running, Postgres instance. It's running Postgres SQL 11. We've done that all with the code. So by that same token, we should be able to run the command Terraform destroy, and we'll take down everything that it finds.